Hello everyone, Alex here. It's the 1st of November and we're on the ramp to Christmas. And I'm looking at my internal goal list and I'm seeing that getting a few more of these videos done is high on my list. It's been about 3/4 of a year since the first video on the channel and I'd planned to post more regularly, but you know how projects go. So I thought it was time to get a good hands-on tutorial / project video back up onto the channel. So why and what am I doing? So one of the things that I've used in previous industrial projects is the CAN bus. The CAN bus is the controller area network. I've used it for things such as controller to node communication, where you've got one main controller talking to distributed nodes on the bus for reading from sensors or actuators. What I haven't done yet is use agents on the bus to be able to read and write and have some autonomy. So it's been a little while since I last used CAN, and I've never used it on the ESP32 at all. So this weekend I decided to build myself a small CAN test bed, partly to refresh my skills and partly to make a tutorial, and also because I know it will come in handy for future projects. I'm already eyeballing 2026 and the next EMF and. So what I did was I grabbed a few ESP32-S3 Super Mini boards from eBay. They're tiny, they fit nicely into a breadboard, and because everyone's using them, they're cheap enough that buying 4 or 5 doesn't hurt at all, really. So why is CAN relevant now? So bamboo printers behind me. I used to run heavily modified Ender 3s and some self-built machines. About the time that I stopped and went more commercial, Clipper and Raspberry Pi based controllers were getting popular, and the CAN bus was starting to show up more and more as a way of running modular tool heads or accelerometers or motion controllers without running massive amounts of cable. When you work on a shared bus, you don't need to run individual cables to end sensors. You can just have a publish and subscribe architecture from those cables. So that idea, one network that connects everything cleanly, stuck with me. I've never really used it in personal projects. I've only used it in industry. So having a small test bed is a good way to future-proof where I want to learn and deploy things to. So in terms of building the test bed, well, the goal was to make a small multi-node CAN rig to see what works and what doesn't. And the thing is that the plan normally goes a bit wobbly when you have your first contact with actual implementation. So putting these things on a breadboard lets you find where the pinch points are before you make a PCB. So when you search ESP32 CAN online, the first thing you'll find is not every ESP32 supports it natively. The newer chips, like the ESP32-S3 and I think the C3, include Espressif's TWAI peripheral, which is their implementation of CAN 2. When I first saw TWAI, I'm like, what is that meant to be? I searched for CAN, why is TWAI or TWAI cropping up? Well, the reason is it stands for Two-Wire Automotive Interface. It's CAN, but a different name. When you actually go on the wiki page for CAN network, you'll find that Bosch licensed the term CAN, so I think it's just Espressif didn't want to have to pay for calling it CAN. I'll actually go and put on screen the GitHub issue list where there's some communication and discussion about this, but basically I'll probably use CAN throughout this video. Just if you're a stickler, know that in the context of the Espressif machines, I'm talking about Two-Wire Automotive Interface, but it's CAN, as far as I can tell. So in terms of the breadboard that I ended up making, that's the full test bed. So you can see that you've got the 4 ESPs, you've got the CAN transceivers, you've got an ESP with a screen, and you've got a spare transceiver for that unit. So what I did to make the breadboard tidier is to get all of these agents online before I did this modification. I would have had to plug in a USB cable per ESP to power everything, and that would have meant 5 cables coming off this board, and that would make everything quite unwieldy to move to just have on the desk. So what I did was each one of those ESPs has a 5-volt rail and a ground. And with breadboards, you have the common rails, which you can use for spreading power. They basically just chain horizontally. So each one of the ESP32s have their 5-volt and ground going into the positive rail and the negative rail of those spines. And what that lets you do is it keeps the wiring simple. It ties all of their 5-volt and ground pins together, so powering one powers the other four. If you try this yourself, it might be, if you're trying to power them all from a lower powered, maybe like a laptop or something that doesn't have a huge amount of current behind it, we might be running into the USB max sort of current drain. You could always try and use a powered hub or something like that, but for me, it's been working fine. So each ESP connects to one of these CAN transceivers that I've bought from eBay, which converts the 3.3 volt logic from the ESP into differential CAN H and CAN L pairs for the bus. So let's talk about the first problem that I experienced going through this. So this is where things got interesting. I programmed each ESP with a simple hello CAN script, so that broadcasted every second with a counter so you can see an incrementing number. And I flashed this to all 4 of the small ESPs and turned them on with one of them connected to a serial monitor, and no messages, no response, and it all just didn't work. So I thought, oh, well, obviously there's an interesting thing here. So what I did was I hooked up the Saleae logic analyzer to the receiver's RX pin to watch the digital line, and the data was wrong. And that's when I realized what was happening. Because I'd bought 5 of these cheap CAN transceiver modules, they included a built-in 120 ohm terminator resistor, which is fine if I only had 2 of them, but because I had 5 of them all on one bus and they were all in parallel, it basically brought the bus down to a point where these transceivers couldn't signal properly. So what I did was I took some flush cutters and I snipped off the termination resistors. I could have desoldered them, but flush cutting was quicker, and they are very cheap transceiver boards. And then the ESP started transmitting and receiving properly. That was really satisfying because this is the first Hello World script that I'm running on these boards, and I'm seeing CAN data now. So that was great. So the next step that I took was verifying this with a USB CAN analyzer. I didn't want to have to plug in a ESP32 with a CAN transceiver to silently watch all of the messages. I wanted to see this data also on the computer. So I bought a Makerbase USB CAN analyzer, and I opened Cangaroo, which is an open source CAN viewer, and I could see my 4 agents on the CAN bus transmitting their 1-second updates with their counters. One problem that I had in setting up Kangaroo was it defaulted to a higher baud rate for the CAN, and I didn't get any messages. You have to make sure that the baud rate from the Kangaroo device is the same as the bus that you've configured. But once you've done that, you'll get your data. I was actually really impressed with the Makerbase USB CAN analyzer. I didn't have to install any drivers, it just worked. I'm not used to that at all for buying the cheaper analyzers from AliExpress and stuff. So just to talk about what I've built. So in the end, I've got 4 ESP32-S3 Super Mini boards talking over CAN. I have 1 spare ESP32 node that is also receiving CAN messages. It's processing them and putting that onto the TFT screen to show live data. And on that bus, there's also the USB analyzer confirming that I can read everything from the computer. So all in all, this was like a 1 or 2 day project that was very easy to implement. I put a bit of effort into making sure that the wiring on the breadboard looked nice. One of the ways that I did this was using a 3D print for cutting breadboard solid core cable to length. What I'll do is I'll put up a picture of the model into the video and a link to the original author. This was really helpful because it saves the guessing and it means that you're repeatable and consistent. The other thing was to make consistent wire stripping from the solid core cable that I was using, I used my Nipex wire strippers, which were really useful as well. So yeah, wrap up and next step. So one thing that I've really realized is any CAN transceiver, I'm going to be checking to see if it's got a built-in 120 ohm terminator on it, and if it has, what I'm probably going to do is just remove it, and I'll explicitly add the termination resistors if I need them. I found that CAN is really accessible, and it's not something that I'm too scared of anymore. I do see there being an issue, potentially, if you're not documenting what signals or what addresses are doing what on your bus. One of the other things that I'm going to do is I now want to introduce CAN into my next sort of project that I'm going to do, because having long-range reliable communication is it's just great. Like, I've used RS485, which is another differential pair signaling technology, but I think I'm just a bit more of a fan of CAN in the way that it's doing its uniform packet structure. So yeah, that's the little CAN testbed, 4 ESPs and another ESP as a monitor, a couple of cheap transceivers, and 1 or 2 days of tinkering that reminded me that it's pretty fun to get hardware working together and to dust off an old skill. It's nothing huge, it's just a solid foundation for me to be able to do some more testing and more interoperability between multiple microcontrollers. Whether the future projects are motor controllers or lighting or just anything else that needs reliable communication, it's good to be able to do that using cheap ESPs. If you want to look into all of this yourself, I'm going to put the source code that I've used, photos of the breadboard and stuff up on my GitHub page. That will be under github.com/EastMakes. So have a look and feel free to build on it and use it. It's quite noddy. It's just some things on a breadboard, but hey, it's useful, for me at least, definitely. So if you enjoyed it, oh god, give a like or a subscribe, and basically keep an eye out for the next project, which should be coming sooner than the last one. I definitely plan on doing something before the next 3/4 of a year. So I'm Alex, thanks for watching, and I'll see you in the next one.